Right. So let's get started. So this is the architecture we were discussing yesterday, right? Like working directory, staging area, local repository. So today let us talk about many other interesting things. We created a file and modified a file. Let us see deleting a file as well. Let's go to our repository. You can open it in your VS Code editor and you have the terminal right here. Check the git status. So, git tree clean means whatever changes you have are all committed and added to the local repository. So, yesterday we have seen git diff. Today, let's talk about deleting the file. Anyhow, I'm creating a new file, or else I can delete this file too. Any file should be fine. So, I'm trying to delete the file. Let's suppose I don't want this file anymore in my local repository. So, how do you delete it? Git rm file name. Just let me add one more file. I want these two files for other scenarios, so I'm just creating another file. You can create a file this way in the Explorer. File 3. Lower, right? You can see the file. So you can see this is unstaged. The first file will be untracked, right? It's a new file, so it is untracked. What should we do now and where is this file now? Can you just quickly answer this so that it would be a quick recap before we proceed for the actual use case today? Git add, right? It is an untracked file. It is in the working directory. And if you see the status, it would tell you like it's an untracked file. It's a new file. So add the file. Add this and then git commit -m third file added, right? So done. That's the way we add it. Okay, fine. Now let's say I want to delete it. Git rm file3.txt. So you can see on left hand side Explorer, the file is gone. When you do ls, you don't have it. Okay, now at this point, what you should do? Like I told you yesterday, Git works with respect to changes. It could be any change. It could be a change with respect to modifying the file. It could be a change creating a file. It could be deleting a file. Okay, so now whatever change I made, you should commit it. See, changes to be committed means the change you made was in the staging area. It could be deleting a file. So git commit -m deleted the file3 actually. Right? Now if you do git status, yes, it's a clean. You don't have this file. Right? That's how you can delete a file from both working directory, local repository, and staging area. What if you want to delete the file only from the working directory? Sorry, only from the local repository. Means I want to keep a file here in my folder because let's say that might be a log file or that might be a project documentation or else that might be a notes I might have taken. I want to keep it in this folder, but I don't want to keep it in the I don't want to keep it in the local repository because I don't want to version control it, or else firstly I just don't want it in the local repository. So how to do that? Git rm cached. What this command will do, and I'm doing it for file 2. Uh, Git rm cached file2.txt. So what this command will do, this command git rm cached will delete the file only from the local repository but not from the working directory. Right? The working directory is the folder where I just want to have a copy of it. So let me try running this command. Okay, you can see minus u here. Do git status to see what happened. It says changes to be committed. Like I told you, right? Whether you delete a file or whether you create a file, you have to commit the changes. So git commit minus m file deleted from local repository. Okay. So now if you do git status, but why is it showing like this untracked files file 2? Can anyone? Why are we seeing this file 2 as untracked? Because it is in the working directory, right? Working directory means git demo folder. Whatever files in this git demo, git will try to track it, right? Because it works like a new file. I removed it from staging area and local repository. It works like a new file and hence it is showing like a add and commit, right? Like an untracked file. It's like a new file. Got it, everyone? It's like a new file. When you create a new file, it will be showing like untracked, right? The same way it was showing because any files kept in this folder will be version controlled by Git because we did Git init to yesterday on this folder and that's a local repository. So whatever present in this folder will be, Git will be trying to track it. It will ask us to add and commit. So that's the reason it will be showing, keep on showing as untracked, right? But let's assume, like I told you already, this file too might be a log file, or else might be a notes which I'm taking, or it might be some documentation which I'm keeping in my folder. I want to keep it in my folder, but I don't want Git to track it. How can I tell Git not to track such some files? Is it possible to tell not to track certain files? Yes. Yes, of course it is possible. You have to create a file called .gitignore, a hidden file again, .gitignore. That's a Git object. Here what you have to do in this file, you keep the file names of whichever you don't want to version control. Save it. Right? See, as soon as you saved this file name, did you see file 2 got grayed out? You don't see minus u there. Let me remove this file name, save it again. Do you see it is being tracked again? Can you follow that? This will not be visible if you just use Notepad as your editor. These are all the advantages of VS Code editor. Here itself you can see on the left hand side panel, right? When I remove the name, it is being tracked again. Git tells it is untracked. But as soon as I added the name of the file and save it, it's gone, it's grayed out. It's not being version controlled, right? So like this, you can add any files, whichever you don't want to get version controlled by Git. Not only file name, let's say I have a bunch of files which is ends with the extension .log. You can use regular expressions like a star .log so that it will not version control any files ending with this extension or else .txt file, something like this. You can use regular expressions to match multiple files and ignore them. So added this file, perfect. Now if you do git status, you clearly don't see file 2 being tracked anymore. But .ignore is being tracked because after all it is also another file. So add this file, it is untracked. So git add .gitignore. Now the status will be changes to be committed. So commit the change. Git commit minus m ignore file added. Right? Done. So now if you do git status, yes, you can see it's not version controlling file 2, but file 2 is still there in my folder, but Git is not bothering about it. That's how you can tell Git not to version control certain files like log files, like documentations, project works, all of them can be ignored from getting version control. Clear with the concept of gitignore? Here I am showing you with a dummy file, sample files. The real implementation of gitignore we'll see once we start our Terraform project. I'll give you an example. In Terraform, there will be some files like called state files. State files are sensitive files with a sensitive data. Such files should not be version controlled and placed on Git. So what we'll do? We will ignore them with a .gitignore. Understood, and is that clear for everyone? Right. Can I proceed? Appreciate your responses. Good to go, or any questions here? Okay. Let me show you the log now. See, there's a huge log. If you want to see the brief history, git log, one line. So you can see the bunch of commit history, right? Let us talk about one thing. How to undo any particular changes. What is meant by undo? What is the dictionary meaning of undo? Reversing the things, right? So undo means reversing. So is it possible to reverse the things here? Let's suppose you created a file. Undo means it will be deleted. Suppose if you have deleted a file. If you undo means you will get the file back. File is created, right? So this is called undo. In Git, we have a concept called revert, right? So what if you want to undo any particular commit? You can undo any commit. So if you undo, what happens? The changes, whatever happened in that commit will be reversed, will be undo. Also, a new commit ID will be generated. Means whenever you run git commit command, a new commit ID will be generated, right? Similarly, whenever you do revert, a new commit ID will be generated. Let's say there's a commit ID called A. I cannot refer this alpha numeric ID, so I'm referring it as A. In this file, let's say file is created. If you revert it, another commit ID B will be generated and the file will be deleted. Right? So new ID is generated. Again, you can revert this B. Like you can revert any commit, revert the revert. This is actually a revert. You may revert it again. Another commit ID will be generated. File will be created. Means A is at the same point as C, or C is at the same point as A. Right? You can do that. You can revert it. You can revert the revert again. You may call it as revert or commit, whatever it is, because whenever you do revert, a new commit ID is generated like a commit. Right? So we are going to do a similar kind of thing now. I'll revert this. You can see 1, 2, 2 to 9. That's, let's say, the assume that is committed. I want to revert it. Revert it means whatever changes happened in this commit will be undo, will be reversed. In this commit, ignore file is created. When I revert it, see this explorer. Here this ignore file should be gone. Okay, let us do that. Git revert. See, it opens an editor. Okay, an editor where you can put some message, like when you do commit, you put the commit message, right? Similarly, you can also put the revert message. Okay, revert message you can put, and this is a Vim editor or Linux editor. Vim editor also we will learn it separately, but for now you can, this is a command mode. Okay, if you want to get into edit mode, escape I. Escape I means it will go to insert mode. Now you can type anything. Like I'm adding some message, reverting ignore file. Okay, so ignore file should be gone. Already it's gone at the, if you see the Windows Explorer. So in insert mode, you type the message, whatever you want to keep. Again, escape. Again, it goes into command mode, colon, WQ exclamatory. That will save and close the editor. That's how you work with Vim editors. Done. So at the back end, you don't see gitignore anymore, right? Now, if you do git status, see, file 2 is being tracked again. Did you notice that file 2 git is tracking it again? Okay. Also, if you see the commit history, see, new commit ID is generated with the commit message we have given. Got it, everyone? So it has created new commit message and the commit ID, and your file, your changes got reverted. What if I want to get the ignore file back? Can I revert this again? This is like a commit B, right? I would like to get it back. Git revert, get the commit ID, first 7 characters is enough. Again, you will get into editor, escape I, and then modify the message like how you want to keep this. Reverting ignore file again, escape, colon, WQ exclamatory. So just see here another new commit. So this is our commit A, this is commit B, this is commit C as per this diagram. See at the back end you can see ignore file is back. Ignore file is back means file 2 will not be tracked anymore. A simple get ignored scenario. Understood? This is commit A. This is commit B. This is commit C. First, we have got the file. We deleted it. Again, we have reverted it. We got the file. This is the actual commit. This is the actual commit we reverted. So in this commit, file is created. When we reverted, new ID is created and file is deleted. We reverted B, we got C. Again, file is back. This is about revert. This is very much helpful in real time. Like whenever you are making any modifications in your repository, when you keep modifying it, this is where you can keep updating, keep changing the files. Like if you want to undo some changes or if you want to get some undone changes, these are all the things you can use. Is this much clear for all? Thank you all for confirming. So this is about reverting, and we'll see another interesting kind of undoing the things. So this is your commit history, right? If you notice, there'll be a pointer called head. Head is a pointer in Git. It will be always pointing to the topmost commit in your commit history. It will always point to the topmost one. So this is pointing to this commit ID, right? Uh, Now let's say if you want to undo any successive, topmost successive, latest 4 commits or latest 5 commits or latest 6 commits, if you want to undo, you can do that. Here you can undo only successive commits. If you undo successive commits means the changes you made during those commits will be gone, as well as those commits will also be wiped off from the commit history, which is called a reset. This is another concept in Git. Reset will help you undo successive top latest or top successive commit IDs. Right? That's a Git reset. When do you use it? Maybe let's say I'm working on this repository from a month. I realize that the changes I made from past 1 week are no more necessary. So I don't want to keep them in the log history as well. So how do you undo that? Right? That's where this reset comes in. Let me show you how to use it. Git and this reset should be used very carefully because changes gone are gone forever. It wouldn't create any commit ID. So changes gone are gone forever. How do you do that? Git reset hard. Let's say I want to get rid of first three. First three means this will be the topmost commit ID. Let's say I want to get rid of first two. Okay, this will be the topmost commit ID. Add it here, whichever you want to be the topmost commit ID. So now it says now head is at head changed. See, now head is changed. Head pointer is here because these two we got rid of. This is one way to do reset. Another way is head tilde whatever number of commits you can get rid of. Let's say this is the commit history now. I want to get rid of these three. So you can use head tilde 3 or else you can use this commit ID whichever will be there as a topmost commit ID once you get rid of the commits. Either way is fine. You can put the specific commit ID which becomes the topmost one after reset or else you can tell how many successive commit IDs you want to get rid of. So I'm doing head tilde 3 now. If you see the log, yes, this became the topmost one. So this is a reset. What is the difference between reset and revert? Did you notice any difference? This will not generate a new commit ID. This will generate a new commit ID. It will generate a new commit ID. It is better. You can use that ID and revert it again, get the changes back. But in reset, it doesn't happen. That's why in reset, changes gone are forever. So you should be very careful. Here you can recover. You can revert them back, right? Also, you revert only successive top commit IDs or latest commits. Here, any random commit ID can be reverted. So which one is safe? Which one do you use on regular basis? Which one is safe, do you think? Revert is the one which is safe, and this is the one we use on regular basis. Reset is it's called very powerful and destructive command. If you use without proper clarity on it, there are chances you may lose your changes which are not recoverable. So you should be very careful using them. So revert is the one which you use on daily basis. And reset is a powerful and destructive command, should be used very wisely, very carefully, only when you are sure you don't want those changes anymore because it will wipe them from the commit history as well, which is a dangerous part. You don't have a history of what changes you made. You will not have those commit IDs. You are losing them. All right. And there's a question from Jyoti. What if we want to commit any specific commit directly, like a middle of commit, then what is the impact of for other commits? You can do any random commit ID. Like I told you, revert can be used for any random commit ID. Like let's suppose you are undoing something like this, right? If there are any dependent changes on it, whenever you do revert, it will show you that message and it will also give you a clue what to do with it. Accordingly, you have to modify them. You have to run those commands. So that is about revert and reset. Is this much clear for all? Okay. So now that you understood how reset works, let me tell you another interesting part called there are different types of resets, but which are very rarely used and which is very far advanced. Okay, you don't need to go and do hands-on or learn it, but for better clarity, I'll just give you a simple chart which will help you understand it very easily because reset is an advanced and a bit confusing concept. So I'll just clarify this, simplify it with this chart. so that when you come across any type of it, it will be easy for you to understand. This is just some additional part. So there are different types of resets, like sorry, um, hard reset, soft reset, mixed reset. Mm. A working directory, staging area, local reverse. When you do hard reset, your changes are gone from everywhere. You will not get the changes back. But in the soft reset, your changes are present in the staging area. If they are present in the staging area, how do you get them back to local repository? What you should do to get it back? Git commit so that you get the changes back, right? If they are in the staging area, that's a soft reset. And there is something called mixed reset. Here, changes are gone from working directory. Okay. Then how do you get it to staging area and local repository? You can do add and commit to get it to staging area and local repository. This simple chart will simplify the concept and will help you understand very easily. Those are the different types of resets. Command is same. Instead of hard, you will put soft, that's all, or mixed, that's all. Commands are same. Okay, you will use hard, soft, or mixed. Give it a try from your end. This is an additional assignment for you. If you are interested to go into this step, yes, you can give it a try. This is not mandatory, but an additional assignment. Try to definitely do this hands-on and see the difference between these three types of resets. Can you give it a try? Everyone? Any questions? So that is about the reset part. Reset, revert, ignore. These are all the very important concepts in Git which help you manage your projects better easily. So what did we discuss today? Git diff. Actually, Git diff is what we discussed yesterday. Git diff is what we discussed yesterday. Today we get started with git rm to remove the file from the staging area and local repository. Then we discussed about rm cached to delete the file from local repository but keep it in the working directory. Then we discussed about gitignore, okay, and then git revert, okay, and then git reset. Git reset, hard, soft, mixed, different types of resets. This is what we discussed today. Any questions or confusions for anyone in this part before I proceed for the next part? Okay. Yeah. So till now, okay, let me run git status. Thank you all for confirming and proceeding ahead. Till now, we are running all these commands, and here you are seeing something like on branch master, right? But what is this branch master? Now let us talk about this branch. What is this branch master, and like why are we seeing like on branch master? Let us understand this concept of branching. Branching is a very important concept of Git which made Git so widely used, and Git works, the branching strategy in Git is so popular, which helps us manage our releases efficiently. So let's talk about it. So branch is like, you can imagine branch is like a virtual directory, virtual folder, or a virtual copy, whatever you call it. Whenever you create a local repository, there'll be one branch created by default, which is called master branch or a default branch or the main branch, whatever you call it. That's a default branch. When still now, whatever changes you made, whatever files you created are all set to be on master branch. That's a default behavior. So everything on master branch. Okay, fine. We have two files. We are on master branch. We are making some changes. We are making some changes for requirement one. Let's say we have some functional requirement one. We are making changes on these files. Client came with another requirement, functional requirement two, and even this file, this requirement also need changes on the same files, but changes are different. Let us say, for example, for requirement one, you need to make changes on 4 and 5. Here, you need to make changes on 2 and 3, let's suppose, on each file, right? So at some point of time, it will be very difficult to distinguish or to differentiate which changes are for requirement one or requirement two, correct? Also, you may have to push this for August, this for December release. Is it possible if you keep them in the same master branch? Imagine branch is like a virtual folder. Is it possible to push them to release them separately? Right? So that's where what we'll do is instead of making all the requirements on the same branch, we will create a child branch from this parent, or we'll create a branch from this master branch. Means when you create a branch from this parent, the child branch will be a copy of this master. You may give some name like, okay, you want to develop a feature FR2. So create a separate branch like this. Once you create a branch, all the files, all the changes from master will be copied here. All the commits also will be copied here. Right? It's like a copy of it. But once you make the copy, they work like parallel entities. Means whatever changes you make in master will not be visible in a feature and vice versa. They work like two parallel entities. Right? So any changes made here will not be visible to master and vice versa. So you can develop requirement one here and requirement two here. You can release them separately, right? This is the concept of branching. Why do you need it? Where do you use it? Yes, to facilitate multiple releases, multiple versions, or different environments. Like you want to maintain different environment, like this is the dev environment, the staging environment, code for staging, right? And then prod, pre-prod. So you maintain branches for environments or to maintain different releases or features and so on. That is where the concept of branching comes in. Git offers a great branching strategies. There are different branching strategies. It depends on the project design and all. So this branching concept is very much helpful in reality. Let me give you a simple example. Actually, we did not remember here, we did not go to remote editor. We are still on our local repository. Okay. Let's say in your local, you have master, dev, staging, and then prod branches. Okay. On remote also, you will have them, right? In reality, you will never make changes on master directly. Let's suppose, let's talk about development project. If development or DevOps, whatever, let's say if you want to develop or make any changes, like let's say as a DevOps person, I want to make some changes to my infrastructure. You will make changes in this branch. Okay. Make changes here. CI/CD will be triggered. Pipeline will be created for this branch. If it is working fine in dev environment, then these changes will be integrated into staging. Integrated means merged. What is merged? We'll talk. Whatever changes in dev will be merged here. Whenever some change happen here, I told you, right, CI/CD will be triggered automatically. So it will trigger CI/CD. It will deploy everything in staging environment. And if it is successful, the same code will be then merged or integrated to prod environment. Then prod pipeline will be triggered. And this prod pipeline, once it is deploying into prod environment, will reach the end users. That's how the changes proceed from each environment, from lower environment to higher environment. Got it right, everyone? Is this much clear for all? Anyway, it's a long way to progress to this part. We'll go creating our branches, creating pipelines for those branches, and we'll see how do you merge from one branch to another, all of that. Right? So coming back, you understood like how you create a branch, right? Like it's a copy of master. You create a branch. Branches could be temporary or permanent. Temporary means, okay, like a draft, you may be creating it to check whether it will work or not. Once it is working, you will integrate, merge them to the actual branch and then delete this temporary branch. Okay, that is one aspect of it. Another aspect is for each environment, you need a branch. So you may maintain those branches permanently for each environment. So you will create branches, you maintain some of them permanently. You sometimes you like you get rid of the branches, you delete the branches in some cases, right? So you could have permanent branches, temporary branches as well. You can delete the branch once it is merged. We'll see how it works. But is this part clear for everyone? Understood? Any questions you would like to have here? If the theoretical part is clear, we'll go for the hands-on. All right, let me go through the hands-on. Just a second. The commands I'm using, everything was there on the uh, website in the lab assignments as well as in the lab notes. The pointer is stuck up for erasing. Give me a second. How many of you are working on Git or have knowledge in Git? Anyone who already know Git? And these would be the revision sessions. How many of you are there who know Git already? Okay, one of you knows Git basics. And Balagan knows basics of Git. Anyone else? Okay, no worries. Let's get started. Uh, okay. So now if you want to see all the branches, Git branch, that will show you the list of the branch, right? As of now, we have only one branch. And let's suppose you want to create a new branch. How do you do that? Git branch minus B, the child branch name. Let's say I'm giving name as B1. You may give feature B1 or whatever. B1 branch and the parent branch, child branch and the parent branch. The syntax is git branch, new branch name or child branch name and the parent branch. And that's the syntax. Okay. So now B1 should be created. What's wrong? Git branch. Oh, sorry. You don't need to have the B flag. Simply branch. Okay. Branch is created. You can see the list of branches now. See, it will show you the two branches list. But star is on master. Star indicates the branch you are sitting on. I'm on master branch. You can see status to see on which branch you are on, or else asterisk indicates you are on master branch. Master branch has got two files, and master branch commit history, if you see git log one line of master, these are the commits I have. Okay, before I go to the master, I go to the other branch, I would like to get rid of this commit history. I would like to go with a simple log history. Git reset hard. I just want two commits to keep the history simple. Okay, done. Now if you see git log, see only two commits. Right? I just want to go with a simple log history. That's all. It's not mandatory you should do reset. Now I'll create a branch because I don't want to continue with the huge log history. I'll create a new branch this time called git branch feature b1. Okay, that's a branch. So if you see the branch history, see you have got three branches, but I'm still on master branch. Now I would go to feature branch. How to go to feature B1? How to switch the branch? Git checkout feature B1. Feature B1 git checkout. So that's how you switch the branch. It is telling you you switched it. It's okay. Just check the branch now. See, star is on feature branch, indicates you are on B1. Not only that, if you do status, it tells you you are on feature branch, right? So both the ways, like those are the two ways with which you can confirm on which you are on. Okay, fine. See, you have the log, two files. You will have the log also copied from master. Right, two commits from master. Perfect. Now I would like to make some changes on this on this feature branch. So let me just create something like file 3. Okay, I'm creating a new file on B1 on a B1 feature B1. I'm writing some dummy lines. Okay, some dummy line I have added. So again, the concept, the whole story is same. Whether you are on master branch or feature branch, your files, like first they'll be in the working directory, you have to add them and commit them, everything would be same. So how to add and commit? What should we do? Git add file 3, right? So now it is in the do status. See on branch feature B1, changes to be committed, same old story. -m on B1 branch, something like this is the commit message. Done. Now on B1, I have three files. Log will show the log of the branch you are on. I'm on B1, so that's a log of B1. So I have a third commit and third file on B1. Do you think you have this third commit and third file on master branch? Do you have them on master branch? Definitely no, because they work like two parallel entities, right? So let us switch to master. Git checkout, git checkout master. Okay, go to master branch and see there. ls, only two files. In the backend also, Explorer got changed, only two files. And if you see the log, only two commits. If you see the log of any other branch apart from where you are on, the giving the branch name will help you. Sorry, you should see the log of feature B1. Do you see that? Got the difference, everyone? So the changes are confined to this particular branch. Those changes are not there on master. Okay. We don't have the third file. We don't have the third commit. Okay. So now let us assume, okay, we don't have anything on this master and I mean the new changes are not there. Let's suppose I want to use this B1 as a temporary branch, as a draft kind of. Right, means I just made some changes on B1, but now I want to integrate changes from feature branch to master. Is that possible to integrate? And there's a question from Jyoti, modified master branch and created new branch from master, then that master branch uncommit changes also committed in new branch. It means all uncommit changes also coming in new branch. No, Jyoti. Only the committed changes will be there in the new branch created from parent. You are creating a branch means all committed changes, all the commit IDs will be there, not the uncommitted changes or the ones in the working directory and all. Only the committed changes. Now I want to integrate changes from this feature branch to master branch. Is it possible to integrate changes from one branch to another? And how to do that integration? That is called merge. Merging changes from or integrating changes from one branch to another. And the syntax is git merge source branch and the destination branch. Source means from which branch you want to bring the changes. I want to bring the changes from source is, this is the source branch, and the destination is master, right? I want to bring from feature of B1 branch to master. So whatever commit IDs you have in feature will be integrated into master. Whatever changes in feature will be integrated into master. Let us do that. Command is git merge feature B1 master. So this is how you do it. Okay. Is this clear? That's a command. Before I run the command, any questions from anyone? Meanwhile, I'm just looking at the topics I covered today. I'm just rechecking all the commands. All right, so let me run this. Git merge. Yeah, you can see like fast forward merge means automatic merge or fast forward merge. So whatever changes in V1 got integrated into master. So that is the concept. If you do ls, you can see all the files from feature branch into master. The third file came in. Also, if you check the log of master, yes, the third commit came in. If you want to compare it with the log of feature B1, yes. Do you see that 2.7 basics came into master? This is a simple straightforward merge, fast forward merge or a automatic merge or a straightforward merge, whatever you call it. Changes were integrated from child branch to parent branch. And later on you can delete the child branch. Deleting the branch we'll see later. Hope this much is clear for all of you. And if you see here, we are still on our local repository. I just want to remind you at this point, we were still here because there are many other things we need to learn before we go for our remote. Got this scenario clear? See, the expectation is after the class, you should do the complete hands-on, right? To gain confidence, to gain expertise on the subject. Do the complete hands-on, which is very important. Git branching and the merge we have seen is called straightforward merge or the fast forward merge, whatever you call it, or else merge without conflicts. There are also scenario where there could be a conflict. Okay, let me show you that scenario. Good to proceed for the conflict scenario, merge with conflict. Good to go. Okay. Let us do a simple scenario. Let's create a simple scenario here. I'm on the master branch, right? So let me see the status. It is all good. I'm creating a new file here. Okay, file 4.txt. A new file on master. You may add whatever content you need. Content is not our interest. So if you see the status now, it will ask us just to add and commit. What should we do now? How to do the commit? Git add file for, right? Now, if you see the status, it will tell us to add and commit. So this is the same old story. By now, you are all well versed with this. So git commit new file on master. Done. Okay, so if you see the status, it is all good and clean. Is this fourth file, fourth commit available on B1 branch? Are they available on B1? Definitely no, right? They are not available on B1. So now what I'll do is, I'm switching to B1 branch. How to switch the branch? Git checkout feature, right? I'm switched to this branch, git checkout. Okay, now let's say I just want to make some changes here. Git checkout. I switch to this branch. Now, as I switch to this branch, here, see, I don't see that fourth file. Okay, fine. Let's say I'm least bothered about other branches. I just want to make some changes. I'm making some change here. Okay. Um, I have a requirement. I need to create this file. Okay. Okay, something like this. Done. Again, the same old story. If you see the file is untracked, okay, like it is untracked, it's a new file. Let us add this file with the command git add file 4. Okay, and then you check the status, right? So commit this, git commit -m, let's say on B1 changes, something like this is a commit message done. Okay, let's suppose I'm done with my changes on B1. B1 is like a temporary or a draft. Now I want to integrate changes to master. Master is the destination. So first let's go to the destination branch. To switch the branch, simply git checkout master. Now here I want to do a merge. I want to integrate changes from B1. So how do you integrate? What is the command to integrate? Just now we learned it. Git merge uh, feature B1 to master. This is how you would integrate. Yes, source and destination. Source is again the feature B1. From B1 feature, I want to get into master. So that's a source. So if I do this, changes would be integrated from feature branch to master branch. So what happens now? Do you think it would integrate softly? Do you think a smooth integration would happen? What happens now? What do you think will happen now? No conflict? Why no conflict? First of all, what is a conflict? Any idea what happens now? So at this point of time, you will get a conflict. What is the reason for conflict? Why do you get a conflict? How to resolve the conflicts? These are the concepts which you have to learn. These are the in-depth concepts. Like you need to get a clarity on what happens now. Right? We will learn this in the next class because this is an advanced concept and also this is the back end what happens. Generally, people do the branching, merging, and they resolve the conflicts without knowing the underlying concept. What happens at the back end? Right? Why do you see a conflict? How to resolve the conflict? And Jyoti says same file exists in master. Is it just same file? To some extent, answer is correct, but not completely. Generally, that's the understanding. People think that it's the same file. It's not just same file alone. There's something else beyond that. Right? We'll see what happens at the back end in the next class. So do hands-on till this part. Do the hands-on for soft reset, mixed reset also, some additional assignments before we before we continue tomorrow. Any more questions from anyone? Any concerns, any questions from the previous topics? Have you all started the hands-on? I don't want to dump all of these things on a day one itself. So we can stop here and we'll continue tomorrow. Prabhu and Balagan have started the hands-on. How about others? I want the response and answers from everyone. Have you all started the hands-on? If not, whoever haven't started, please try to do the hands-on. Hands-on is a mandatory and equally important as the class. Okay, Rajan have also started the hands-on. Good to know. And Jyoti have started. That's good to know. Okay, there is a hand raise from Munna. Let me. I don't. Yeah. Okay. Yes, I have allowed you to speak. You can unmute and. Hi, Munna. Any questions? Hello. I can't hear you if you are speaking. If you are not, please check your mic and let me know if you have any questions. Yes, Munna, I can hear you, but not what. Can't hear you. Some sounds of the mic. Meanwhile, anyone else, any other questions regarding the previous topic or any questions? We are learning here thoroughly, right? Like what happens at the back end, what is what and all. If you already know or working on it, you will see the difference of how the concepts were dealt with, right? You might have seen the difference of how depth we are going into. So please go through the recording, do the hands-on. That will be a question from Munna. How can I get recording of previous sessions? All the recordings will be there in your LMS, Munna. LMS access is there. Everyone. If you haven't be having a free trial access. I think everyone is enrolled by now. One without enrollment, so everyone have enrolled into the course. So please check your LMS access. Okay, log into this website preethidevops.com and check the trial access first, and then once you are enrolled, you should be having the complete access as well. Go to this website preethidevops.com. Okay, here create a free account and log in from this menu, My Learnings. If you go to the My Learnings, you will see the program for June batch here. You will see the June batch program. Once you go here, here are your recordings. Like Git topic is Git day 2, so you should be seeing the recordings. Recording will be uploaded after the class. This is April batch LMS. So you should be having your batch. If any questions in accessing the LMS or regarding the enrollment, reach out to Mr. Raj on this number. You are seeing this WhatsApp number, right, on the website. Please reach out on this number for the access details. Not able to see them. Hope that is clear. Is this your first? Can you show where to find your files, like installing it? Okay, those will be in the lab notes. In your LMS also you can see, or here is the lab notes. Or once you go to your LMS, My Learning, View Program. Okay, here this one, yes, lab notes. Okay, from here you can go, or else from the like you can go. Here it is. So if you go to Git, here is the PDF or the presentation I have used and the architectural diagram. Always keep this architectural diagram beside you when you are doing hands-on to relate perfectly with the working directory, staging area, and loop. That's how you should learn. Okay. So that is all this year and will continue tomorrow. But before the class, I am expecting everyone to complete your hands-on and the quiz and the assignments which you see on your LMS. Like these are the things you need to complete before you join the class tomorrow. Lab exercises, quiz, interview questions relevant to this particular topic complete. All right, then have a good day. Bye, everyone.